So again, any questions, guys? Shh. On, first of all, looking at the substitution, before you look at the answer, make sure you plugged in the correct ratios into the formula. So any questions on how I did the substitution of the ratios, first of all, into the formula? Remember, 5 times negative 3 is negative 15. 13 times 5 is 65. And then 12 times 4 is 48 over 65. Watch your negative signs, guys. Okay? So, tangent. Again, like I said, guys, tangent's always going to give you those little twists and turns and tricks. So, tangent of alpha minus beta from your tangent difference formula. Tangent of alpha minus tangent of beta all over 1 plus tangent of alpha, tangent of beta. So again, we've already set up the tangent ratios. So tangent of alpha is 5/12. Tangent of beta, watch your negative signs. Tangent of beta we found to be negative 4/3. Over 1 plus tangent of alpha, which is 5/12. Tangent of beta, which is negative 4/3. Shh, guys. Shh. Any questions on how I did the substitution into the tangent difference formula? Issue's going to be with tangents, guys, is you're usually going to have a complex fraction and or radicals to have to simplify. Any questions on the substitution that I've done? Well, what happens in the numerator when you have minus and negative? Minus and negative becomes a positive. So 5/12 plus 4/3 over 1. Now remember, you want to multiply the fractions before you add them, so that's going to give me a minus 20 over 36. The LCD trick that we've been practicing, ladies and gentlemen, with variables works when you still have integers as the denominator. Notice you've got to simplify the complex fraction first. You've got a 12 and a 3 and a 36. The LCD is going to be 36. So just like what we've been practicing doing, I'm just going to multiply everything by a 36. Yes, if you really love adding and subtracting fractions together, if you really want to do this the long way, get a common denominator, subtract the numerator. Get a common denominator, subtract the denominator. Then multiply by the reciprocal. But I do not know why you guys want to still continue to do that. The LCD trick is much quicker. It takes a lot less work. So when I multiply 36 over 1 by 5 over 12, I can cross cancel. 12 goes into 36 3 times. 3 times 5 is 15. Plus 3 goes into 36 12 times. 4 times 12 is 48. So notice, poof, all those fractions are gone in the numerator. 36 times 1 is 36. You can cross cancel the 36s. That's going to give you a minus 20. So 15 plus 48 is going to give me 63 over 16. And you're done. Okay? That, like I said, guys, tangents are going to be the one that require the more work. All right? Because usually you're going to have complex fractions and or a radical to contend with. So just be prepared for that. All right? Any questions on that? Let's take a look at another one. So, oh, by the way, there's a typo here. Change this to alpha. Change that V to a beta. So change those U's to alpha and change the V's to beta. First of all, guys, before you even get started, let's set up the triangles. So they're telling us that the tangent of alpha is a half, and that alpha is located from pi to 3 pi over 2. Location, location, location. What does that tell us about angle alpha? What quadrant is between pi and 3 pi over 2? What quadrant would be located? 3. Because remember, this is your pi, this is your 3 pi over 2. So I know I'm going to be down here in quadrant 3. Now, by your SOHCAHTOA, what sides of the triangle does alpha represent? Your TOA. Tangent's your what? Opposite over the adjacent. So the opposite side is 1, adjacent side is 2. Do you need negative signs in front of either of those numbers? Are you on the negative side of the x-axis?
Yes.
Yes, so you better put a negative sign in front of the 2, remember. Are we on the negative side of the y-axis?
Yes.
Better put a negative sign. How are we going to calculate this third side? What theorem do we have to use? So 2 squared plus negative 1 squared is equal to c squared, because you're solving for the hypotenuse. So 4 plus 1 is equal to c squared. So 5 is equal to c squared. So what's that hypotenuse going to be? Square root of 5. So now that you've got the 3 sides, go ahead, whether you do it now or later, you can go ahead and set up those other trig ratios. I know tangent of alpha is a half. What's the sine of alpha going to be? The sine of alpha is going to be the opposite over the hypotenuse. So that's going to be negative 1 over square root 5. Wait to rationalize.
Wait, what?
The sine, SOHCAHTOA.
No, why is negative 1 over...
So the opposite of alpha is negative 1.
Oh, okay.
Hypotenuse is square root 5.
Okay.
Cosine is the adjacent over the hypotenuse. That's going to be negative 2 over square root 5. Like I said, whether you do it now or later, usually I like to get my triangles and set up all 3 ratios all together. Okay? So any questions on my alpha triangle? Now I need to do the same thing, but I need to set up a triangle for beta. Now be careful. Look at the location of beta. Beta is located from negative pi over 2 to 0. So it's a negative angle. Where is negative pi over 2 to 0 going to be located? What quadrant? 4. So now they're giving you the sine of beta is negative 4/5. So label 2 of the sides of the triangle. Again, your SOHCAHTOA, sine is the opposite over the hypotenuse. So my opposite side is negative 4. The hypotenuse is 5. If you recognize this is a Pythagorean triple, or you have to use your Pythagorean theorem, what is the third side of the triangle going to be? It's going to be, is it positive or negative, first of all? Positive, because you're on the positive side of the x-axis. And what is it going to be? It's going to be a 3. You've got a 3, 4, 5 triangle there. One of your Pythagorean triples. So they gave you the sine of beta. Set up your cosine of beta. Ka, from your SOHCAHTOA. Adjacent over hypotenuse is going to be what? So what's the cosine going to be? 3 over 5. Tangent of beta is the opposite over the adjacent. So that's going to be negative 4/3. Okay? So you guys now for this one, using those 2 triangles, see if you can find the cosine of alpha plus beta for me. Yeah. Yeah.